I'm out at the bus today. It's Monday. Yesterday, I didn't have enough going to pull the batteries down while the solar was in the sun, or, well, in the clouds, really. Today, it is full sun, noon. And I brought a 1500 watt heater. I'm, of course, not going to run 1500 watts. And actually, I need to hook it up through the kilowatt. I don't know exactly how much it'll pull, but I'm not going to run the whole 1500 watts. That would be just too much. But we'll see how the solar panels do when I put a real load on it. Be right back. Right now you can see they are completely full, 14.57 volts. Yeah, whatever. Let's find out what happens when I turn this heater on. 390 watts on low. Let's kick it up to medium. Cool. So around 750. There we go. 385. That's about half what its max is. But then again, this is winter and the sun is in the southern sky, so. And that is really, really hot. As you can see, it is on medium. And still pulling 750. Cool. Wonder how long it'll take to drain them down. Let's find out. It's been 7 minutes since I started the 750 watts. 387 coming in, and it is at 12.83 volts. Still nowhere near danger zone. And yeah, I'll be back. 14 minutes, 12.7 volts. Still nowhere near the danger zone. 12.3 is the danger zone. Keep an eye on it. I went and got the ladder so I could check and see if my leak proofing worked, and it did. However, there is another problem. Something I've been thinking about is these panels are only held down with self-tapping screws in fiberglass. Well, what happens when I'm going 60 miles an hour down the road and wind gets under here, and it will, and decides it wants to lift this up? All there are 4 tiny self-tapping screws holding it. I could be paranoid, but I don't think that's going to hold it. So what I'm thinking is get a small metal plate, a bunch of them actually. I'm going to do every single panel. And instead of self-tapping screws, I'm going to use those plates, drill through the roof. Oh, I thought that was wet. It's not. Looks like it. Put a plate here and a plate over there. Drill through and anchor through with the metal plate, like maybe that big each. And that way, no matter how much it pulls, it cannot pull the whole panel off, because there are 3 layers of fiberglass, and well, it just can't pull that. And it is getting really, really hot in here. 408 watts, 409 watts. Cool. 17 minutes. Batteries are still pretty much full. And that's with a 770 watt draw. Let's check amps. 7.2, multiply that times 10. 72 amps coming out, 75 maybe. And it would help if I'd hold the camera still, sorry. 770 watts. So yeah, in full sun, there's 402. In full sun, I could easily run 750 watts for quite a long time. Which is good, because that means my air conditioner will run just fine. In full sun. Okay, it's been 20 minutes. Batteries are still nowhere near in danger. They're still at 88%, 85 to 88%. I'm going to go ahead and stop it. I just wanted to make sure that I could do it, because in the summertime I will be running my air conditioner. And I wanted to see what the solar panels would get to in the winter. And they got to 402 that I saw. In the summer, when the sun is directly above, it should get a whole lot more than that. I'm going to go ahead and shut off the heater. 0 watts. Good. Shut everything off. And now let's see how long it takes to go back up. Apparently not very long. Alright, 9 minutes later, it is back up to maximum. So yeah, doesn't take very long at all to charge them back up. Thank you for watching. If you liked the video, click the thumbs up below it. If you want to stay updated with everything that's happening and all the travels that are soon to come, click the big red and white blinking subscribe button with all the arrows.